Okay, so in this case, we've got hydrated copper sulfate, and we've been told what the hydrated mass and the anhydrous sample mass is, and we've been asked to figure out what the value of X is, right? As you can see, the coefficient next to CuSO₄ is effectively 1, right? I mean, it's not a number before it, but we can infer that the number is 1 here. Now, for the H2O, in order to figure out the value of X, what we want to be able to do is compare the number of moles of CuSO₄ and the number of moles of H2O as a ratio. So we want to compare that, and this is important because what we're given here is masses. We're not given, even though we're given masses, they have different molar masses, right? So we do need to convert them to a format that's actually comparable. Okay, so how are we going to work out the number of moles of each? Well, we're going to use the equation that links them, which is that the number of moles is equal to the mass divided by the molar mass mR, right? And so for CuSO₄, we've got that the mass is 2.98 grams, right? So the anhydrous sample mass is 2.98 grams. So that for the number of moles of CuSO₄, it's going to be 2.98, and then that's going to be divided by the molar mass of CuSO₄. But we need to work out what the actual molar mass is to get the number for that. So let's refer to the periodic table, right? So for CuSO₄, we're going to need copper, sulfur, oxygen, right? So that's effectively going to be 63.5, right? So the Cu S, so 30 plus 32.1, and O4, right? So that's going to be plus 16 times 4, right? And that's going to give us the MR of the CuSO₄. So in this case, that's going to give you 159.6, right? Okay, so and that's going to be in units of grams per mole, right? So we take the 159.6, and that's going to give us the number of moles of CuSO₄. So if you do have a go at working that out, what you should find is that you get 0.18672, right? Actually, that is let me just correct myself. This actually is 0 here, so 0.018672, right? And that's going to be in moles, and that's to 5 significant figures, right? Okay, so the other thing we're going to need to do is work out the number of moles of the H2O, right? So for H2O, we don't have a value for the mass of H2O directly. We do need to do some arithmetic to figure out the mass. So we've got the hydrated mass, we've got the anhydrous mass. So if we subtract the anhydrous mass from the hydrated sample mass, we would get the mass of the actual H2O, right? So if we do 3.34, so this is just, we're trying to work out the mass of H2O, okay, in our sample. 3.34 minus 2.98, right? So if you work that out, you should find that comes to 0.36 grams, okay? So that's going to be the mass of H2O. And so therefore, in terms of the number of moles of H2O, that's going to be equal to 0.36 divided by the molar mass of H2O. So you may already know what the molar mass of H2O is. It's you know, comes up quite commonly, but we can just use the periodic table. So hydrogen, H2, so it'll be 1 times 2 plus the 16. So that's 1 times 2. So that's for the hydrogen component plus the O part, right? So H2O, so 16 plus 16, right? And so that's obviously going to give us 18, right? And that's going to be in units of grams per mole, okay? So that's going to be the mole mass of H2O. So if we insert that, so MR, so it's going to be 18. Now this is going to give us the number of moles of our H2O, right? And if you do work that out, what you should find is that that's 0.02 moles, okay? What we want to do at this stage is actually establish a ratio between the moles of, and here's the thing, with our formula here, we've got CuSO₄ on the left hand side. So we want to put it on the left hand side, just for the sake of clarity. So the number of moles of CuSO₄ as a ratio compared to the number of moles of H2O, right? And that's going to effectively be 0.01867 as a ratio compared to 0.02, right? And what we want to be able to do is get both values to well, not both values, but we want to get the value on the left hand side, the CuSO₄, the moles, to be 1, right? Because in our formula here, we've got CuSO₄ dot and then the XH2O. So we want to get this value to, because effectively we've got for 1 mole of CuSO₄, how many moles are we going to have of H2O? That's really what the question is, right? So how can we do that here? Well, one of the ways we can do it on the left hand side is simply dividing the value of moles by itself, right? So divided by 0.18672, and because we've done that to the left hand side, we also do need to do that to the right hand side as well, right? So that's going to be also divided by 0.18672, right? So of course this side is going to become 1, right? And on the other side here, we're effectively going to get 1.0711, okay? And at this stage, you probably have noticed that this is very close to 1, right? And we're going to do some rounding at this stage. We're going to round this side to the closest integer value, and if you do that, of course, you're going to get 1, right? So because of that, right, what we can conclude is that the value of x is actually 1, right? So x is equal to 1, therefore it's going to be CuSO₄, right, and then 1 H2O, right? But of course, because we have a 1, we could literally just write CuSO₄ dot H2O. We could just write that, but for the sake of you know, just numerical clarity here, entering our value for x, we would put that the value for x here is 1, right? Okay. All right, yeah. So that's, yeah.